Chapter 14, Section 5 in the 8th grade note-taking guide is entitled Multiplying Polynomials by Monomials. So what they're going to start off with here is something a little bit easier than what they've described. They're actually going to start off and just multiply together two monomials. So let's go ahead and look at questions here where we're multiplying monomials together. All right, if we take a look at what we've got here in 1a, we've got 2x cubed y squared being multiplied by 6x to the 5th y cubed. So, as a matter of fact of putting these together here, we know what to do with the integer parts right away. If we're multiplying and I've got integers, I can do that. We've been doing that forever. So we can go ahead and put the 2 and the 6 right away together here to make 12, which is what you see as part of the answer here. Now, it's the exponents and the variables that worry me. Hopefully you remember the product of a powers rule. The product of powers rule says that when you have variables, and you're multiplying them together, the parts with the same base, when combining them with multiplication, you actually add the exponents, which is why out here in the directions it says we are to add the exponents. So if we look, for instance, at the x's, here is x cubed, and over here is x to the 5th. Well, what the rule says I'm supposed to do here is not to multiply these together, even though this is a multiplication problem. The rule says I'm supposed to add the exponents together. So that's going to combine to actually make x to the 8th, which is what you can see that they've written here as part of the answer. Let's do that one more time with the y's here. We've got y to the 2nd with y to the 3rd. Well, again, the rule says in a multiplication problem, when you
have like bases, these are both y's as the bases. When you have like bases, you go ahead and you add the exponents. So I'm going to add the 2 and the 3 together, and that's going to combine to make 5. And that's where the y to the 5th part of the answer comes from. It's not difficult, it's just a matter of remembering that rule as we go through this here. All right, so if we look at 1b here, we've got 9, a to the 5th, b to the 7th being multiplied by negative 2, a to the 4th, b cubed. So if we take a look at the integer parts here, we've got a 9 and a negative 2 I'm multiplying together. That's going to give me negative 18. A to the 5th and a to the 4th, that's going to combine to make a to the 9th. Remember, we're adding the exponents, so that's where that part of the answer came from. And then b to the 7th and b to the 3rd combines to make b to the 10th. I want to remind you as well, because they could do this and there would be nothing wrong with it, if you have a negative exponent, you still add in the negative exponent here. Because it's still part of a product. The problem will be is if that solution part works out to be negative, you've got to take that negative part and flip it to the other side of the fraction, which then makes it positive, and then you can write that as part of your solution. But of course, here, while you can do it for multiplying, your answer isn't really a polynomial then, because as you know, we're not allowed to have that negative exponent. So we can do it. We have the process to do it, but it's not really technically legal here. Okay, so now as we go down and take a look here at number 2, in number 2 now the question switches. Now they're going to take a monomial and multiply it by a binomial. So what they're really doing here, the way they've set this up, is they're doing distributive property here. So if we take a look at what we've got 3m, and it's being multiplied by 5m squared plus 2m. So let's go ahead and take care of that here. So you can take the 3m that's in front and multiply it through to both parts as they're showing you here. So the 3m being multiplied by the 5m squared. Well, 3 times 5 is going to give me 15, as you can see. And then the m being multiplied by m squared, well, that's like m to the 1st being combined with m to the 2nd. Well, as you saw on the last page here, we add the exponents. So that's actually going to combine to make m to the 3rd, which is what you can see they wrote here. Then we've got our addition sign, which just drags down. And then I'm going to do 3 times 2. Well, 3 times 2 is going to change into 6. And then I've got the m and the m, which is going to combine to make m squared. So that's going to give me 6m squared.
And there's nothing you can do beyond this because m cubed and m squared are not like terms because they have different exponents. And so that's your final solution. Now as we take a look at question number 2, it says negative 6x squared y cubed being multiplied by the polynomial 5x y to the fourth added to 3x to the fourth. So again, this is more distributive property, me taking what's in front of the parentheses and multiplying it through to the things that are inside the parentheses. So the negative 6x cubed y squared has to be multiplied through to 5xy to the fourth. It also has to be multiplied through to 3x to the fourth. So let's take the negative 6 part through to the 5 part. Well, the negative 6 times 5 is going to give me negative 30. X squared and mystery x here doesn't have an exponent, so that's a 1. X to the first are going to combine to make x cubed. Remember, we're adding the exponents because this is a multiplication problem. And then y cubed being multiplied by y to the fourth makes y to the seventh. Now, you can see here that there's an addition sign in the middle, but when they transcribed it, they've written minus. The reason why is because in the next part here, they're going to start off and do negative 6 times 3, which is actually going to give me negative 18. So instead of writing plus negative 18, they just wrote minus 18 there. So I wrote the minus 18, and then I got to take the x squared through to the x to the fourth. That's going to combine to make x to the sixth. And then y cubed, and that just gets transferred down to the answer y cubed. And so we end up with minus 18x to the sixth y cubed. Now as we take a look at the next question here, here's our problem solving question. It says the length of a picture frame is 8 inches less than 3 times its width. Find the length and width if the area is 60 inches squared. Alright, so we're going to call the width of the frame W. And then from that, we can generate the length, because what they said here is it's 8 inches less than, or otherwise subtract 8 from that W, but it's 3 times that width. So 3 times W minus 8. So the answer here is going to be a value of W that makes the area of the frame equal to 60. All right. Now, obviously here what we're doing is we're solving this using the distributive property again, which is why it fits in this section, because that would imply that we're going to have to multiply, and this section is about multiplying. We're taking the length, 3 times W minus 8, and multiplying it by the width, which we've called W. So when I take W and multiply it by 3 times W minus 8, with the distributive property, that's going to give me 3W squared, 3 times what would be in effect a coefficient of 1 is still going to give me 3, and WW is going to give me W squared. And then I'm going to multiply the W through. 8 times W is going to give me 8W, and as you can see, we've got subtraction in the middle there. Alright, so 3W squared minus 8W gives me a polynomial expression equal to the area of the picture frame. So now what they've decided to do is they've decided to try different numbers until we pop up with a solution of 60. So they start off with 3 and they progress up here. Obviously this last one happens to be the solution. Want to make sure you use order of operations, which is another good thing to talk about here. Remember, when we're doing order of operations, exponents come first. Then we can go ahead and hit our multiplications that we see here. So when they plug in 3, it's 3 times 3 squared minus 8 times 3. Well, 3 squared is going to change into 9. 9 times 3 is 27. And I subtract 24, which is 8 times 3, and I get 3. Well, remember, my answer is supposed to be 60 here, so I know that this one just didn't work. So I try it with 4. 4 squared is 16, times 3 is 48, and then if I subtract 32 here, 8 times 4 is 32, I get 16, not 60. So 4 is not the answer. 5 squared is 25, times 3 is 75, and if I subtract 40, which is 8 times 5, I get 35. Well, that again is not 60, so that one doesn't work either. 6 squared is 36, times 3 here, 36 times 3 is going to change into 108, and if I subtract 8 times 6, which is 48, I pop up with a solution of 60. Well, that's great because we've got a solution of 60. The question said the area is going to be 60. So plugging in 6 gave me the correct width. All right, so now that I know that W equals 6, now I'm going to apply it to that polynomial to find that length. Remember, that polynomial is what we found way back up here in step 1 for the length. It's this 3 times W minus 8. So I'm going to do 3 times 6, which is 18, minus 8, which is 10, and that's going to give me the length, which is where they're coming up with this length answer. So if the width is 6 and the length is 3 times that minus 8 or 10, that would indeed give me an area of 60, and thus my answer is reasonable. All right, so let's go ahead and take a look at the check it out examples here. Number 1, we're multiplying together 5r to the 4th s cubed and 3r cubed s squared. So remember, we're going to combine our integer parts. 5 times 3 is going to go together to give me 15, which is what you see there in the answer. The r to the 4th and r cubed are going to go together. Those are going to go together to give me r to the 7th, which is what you can see is the second part of the answer. And then the s cubed and the s squared are going to go together. And that's going to go together to make s to the 5th, which is the final part of the answer. Again, remember, the product of powers rule says here when you multiply together powers with the same base, all right, in this case here the r's, in this case here the s's, you add the exponents. So here you're going to add for 7, here you're going to add for 5. That's where those answers came from. Now number 2 is a repeat of the distributive property. We've got negative 3a cubed b squared being multiplied by 4ab cubed added to 4a squared. So you're going to take this negative 3a cubed b squared and multiply it through to 4ab cubed and 4a squared. So if I take it through on the first part here, negative 3 times 4 is going to give me negative 12, which is what you can see right there. The a cubed and the a are going to combine. That's going to give me a to the 4th. Remember, if it doesn't have an exponent there, it's like a 1. So this is like a 1. And again, the rule says, as we just discussed again in number 1, that we're supposed to add the exponents together. 3 and 1 adds up to make 4. And then I've got b squared and b cubed. That's going to combine to make b to the 5th. Again, adding the exponents. Now we see a plus sign in the middle here, but then we know we're going to get hit with negative 3 times 4, which is going to change into negative 12. So they wrote minus 12 here. They could have written plus negative 12 would have been fine. A squared being multiplied by a cubed gives me a to the 5th. And b squared is not going to partner with anything, so it's just going to get dragged into the answer here. Reason why is there's nothing with b over here, so it gets just dragged into that answer, and there's b squared. As we look at the concluding example, it says the height of a triangle is twice its base. Find the base and the height if the area is 144. So here we go. We've got a triangle. I don't know what type of triangle, so I'm just going to draw regular old triangle, and we are told here that the height is twice the base. So if the base is b, which is logical, then the height has to be equal to 2 b's. Now, formula for the area of a triangle, which is what we're going to have to use here, says we take the base times the height, so b times 2b, and then we divide that by 2. And here we're told at the end of the line here that total area is going to equal 144. So this statement here is going to equal 144. Well, let's go ahead and simplify this. This isn't a big deal to simplify because we've got b times 2b. That's going to combine to give me 2b squared. b times b to the first and b to the first combines to make b to the second, of course. And that's divided by 2. Well, the 2's are going to cancel each other out and tell me that the area is just b squared. b squared equals 144. 144. How do I know it equals 144? Again, the last line tells me there that the area equals 144. That's how I know that. So, I want to find b. How do I find b? Well, you know how to get back from b squared to b. We're going to do this just like when we were doing Pythagorean theorem is really when we emphasized it. We go ahead and we take the square root of both sides. The square root of b squared is b, and the square root of 144 is 12. So the length of the base should be 12 inches. Since the height is 2 times that, the height is going to be 24 inches.